Okay, so this is another relatively short section in our theory notes, where at the conclusion of this chapter we're looking at which graphs do we use to represent different situations? How do we make those decisions? What is most suitable? So thinking about bivariate data, which is what we've been looking at most recently, so where we have two variables and we're trying to identify associations or compare them or see what's happening. We've looked at a number of different ways of representing that data. So we want to have a think about, given the variable types that we've got, what might be most appropriate. So the first category in the top left of this table, I've got 4 grids here, would be where we have a categorical explanatory variable and a categorical response variable. So associations with two categorical variables. And generally speaking here, we're looking at a segmented bar chart where we can see, for example, that we've got one of the categories on the horizontal axis, and the second category is represented by using the key in the segments of the bar. We can also use the same sort of information using a side-by-side or a parallel bar chart, where again we do one variable on the axis and then the other variable again is about the key. We represent that in a slightly different way here. So these are essentially the same thing. The other thing that's missing here, which we did use quite a lot in this section, which I'm going to add here, is a two-way frequency table. Would also be a way of, two-way frequency table, which would also be a way of representing two categorical variables. The second group we're looking at is where our explanatory variable is a categorical variable and our response variable is numerical. So again, we've got a couple of different representations here, and we looked at these in the particular section, the particular video where we compared a categorical and a numerical variable. And we could use a back-to-back Stemplot. Obviously the limitation with the back-to-back Stemplot is we can only have a maximum of 2 categories because we don't have anywhere else to put a third category. So we can have 2 categories. In this case, maybe they're marks on a history test and an English test or something. So we've got the 2 subjects and then the stems down the middle with the leaves extending out either side. So we've got the subjects being the category, and the response variable, the numerical variable, being the marks scored on the test. Okay, the explanatory variable being the subject. I should have said. So again, limited though to only 2 categories. Down the bottom here, we could also use a parallel dot plot, and again, this is really very similar to a parallel, back-to-back stem plot. We draw the dots for one variable, so we've got 2 categories here. We've got the diving score, and the 2 categories are day 1 and day 2, the diving score being the numerical variable. So day 1, we're drawing our dots going up above the axis here. Day 2, we're drawing our dots going down below the axis here. Again, we're limited to 2 categories here, although it actually is possible to do parallel dot plots by just, again, you have one dot plot here, whatever, you have then another dot plot here, obviously with the same scale, and you put them above each other. We did an example like that back in that video, and we could therefore then put a third one up here. But again, dot plots and stem and leaf plots are both a bit limited, probably better when you don't have too big a data set, and also obviously the numerical data needs to be discrete. Whereas a parallel box plot is going to be a bit more flexible. We could use a much bigger data set, and it could be discrete or continuous data. We could and again, we could have as many categories as you want. We could just keep stacking box plots. So here we've got a situation with 3 categories, 3 different age groups, that's the 3 categories, and then the numerical variables represented on the axis down here, which is the annual superannuation contribution. Okay, and we're able to compare them that way. So the parallel box plot's probably the most flexible in terms of big data sets, continuous data sets, and also being able to have lots of categories. We don't have situations where the where the numerical variable is the explanatory and the categorical is the response, so that's irrelevant. And the third situation, yes, there are 4, but one's irrelevant. So the third situation is when we have 2 numerical variables, and in those instances we use a scatterplot. Okay, so thinking about your plot choice given the sort of data that you're dealing with. There's also a little summary down here of univariate data when we would make choices. We've covered univariate data a couple of chapters ago, but generally categorical data we'd be looking at using a frequency table, a bar chart, possibly a pie chart or a dot plot. And numerical variable, we could also use a frequency table or a bar chart if the data was discrete. If it wasn't discrete data, we would use a histogram instead, and we'd group the data. We could use a dot plot again. We could use a Stemplot or a box plot if we have numerical data. So being able to make those decisions about, given the data type here, what's going to be the most appropriate plot choice to represent that data.